Hey guys, welcome back to my channel. My name is Aditya and today we will be discussing about Southern Tanner Crab geospatial data analysis. So we will be basically analyzing the population of Southern Tanner Crab, where it is located and where it is located mostly and where it is located rarely. Like the place where we can find it out easily and the place where we can find it out rarely. So let's get started. uh, this is my Kaggle notebook in which I have coded this project. The purpose of using Kaggle notebook is you don't have to download the database. Also you get a GPU here. So we can also think of Kaggle Notebook as a replacement of Google Colab. So the first cell basically imports all the required libraries such as NumPy, Pandas, and it also like imports our data frame file or the CSV file in it, which is this southern tanner crab dot CSV. It will import the CSV file in our notebook. So I have already run this. Now we are reading our data frame. We just copied this path of the CSV file and then we are reading this using pd dot read underscore CSV. Then using df dot head we'll see a glimpse of our data frame. So here is our data frame and it has a column ID, latitude, longitude, year, name, sex, bottom depth, surface temperature, bottom temperature, hall and CPUE. All the necessary columns we have, but for our analysis we only need the latitude and longitude column since we are analyzing only on the geospatial data, so we don't require any other columns. If you want to see how a data frame looks like from the bottom, we can use df.tail and we can see there are around 17,000 rows in this data frame. So this is how huge our data frame is. Then we want to see the non-null count, like if everything has a value. So the latitude and longitude all are non-null and the data type is float 64. So we shouldn't worry about any null count since every row has a value in the latitude and longitude columns. So moving forward, because we just need the latitude and longitude column, so we'll reduce our data frame to 1 1:3, since the column number of latitude is 1 and longitude is 2. So and we'll access all the rows and then we'll reset underscore index. We'll convert this into a data frame. So I'll name it as data, and if you I want to see a glimpse of my data frame how it looks like, this is the index, latitude and longitude. So next I'll be using this rush data frame to analyze how many I'll group by the data on latitude and longitude, and then I'll access the index to analyze how many number of crabs were found on each latitude and longitude. So this will be my rush data frame and I'll be plotting my heat map on the rush data frame itself. Then I'll use count and reset underscore index to convert this into a data frame. This we all know. And how this is how my rush data frame looks like. It has three columns: latitude, longitude and index. So you can see how many crabs were found on this particular latitude and longitude. Next, what we'll do is from Folium.plugins. Again, Folium is a very important library if you are analyzing on geospatial data. It is especially built for analyzing data on geospatial data such as latitude, longitude, and many such things. We'll import heat maps since we'll be plotting. As I already said, Now what we'll do is from folium.plugins we will import heat map, and then we'll import Folium, and then we'll write base map equals to folium dot map, and then we will plot our heat map of rush to the base map, and then we'll write base map to print what it looks like. So this is basically what we got here. So here what we have done is we have analyzed the population of southern tanner crabs at various places. So at the boundaries it's the lowest, and in the center it's the highest. You can see from here these are the areas where the population is somewhat less, whereas in these areas the population is very high. So this is how we can analyze using Folium. Thank you.